All right. Let's briefly go over where we're headed in this stream. Might be a shorter stream. Probably have to go less than an hour. We'll see. Yeah, so we want to design something that's going to let people spin up an OCaml based web app as quickly as possible. So think like create next app or the Laravel's, I can't remember what it's called off the top of my head, the artisan commands, the setup for Laravel, right? We just want some way to be able to have a project set up, start running, and already have a web page displayable and some like stuff hooked up. I think preferably I'd like to have SQLite already stood up as well, just because that doesn't require any additional hook-ins. We'll have to see though. But for sure a web page. I think we'll use Dream. I don't know. I think I want to use Dream, but on the other hand, I'm sort of like not sure if using Dream is going to be the best case scenario or if we just build our own thing. Building our own thing is a lot more work. Why is there 2 B's in this web? Yeah. So the other thing that we have to overcome is that we need some way to be able to run this command after OPAM install, because we want to be able to do something like OPAM install huckabuild. I don't think huckabuild is going to be the name, we'll see. I want to be able to do something like that, and then it installs, and then you can do something like whatever the name of our thing is, huckabuild setup or huckabuild new, or yeah, huckabuild new, my project name, right? Command phone huckabuild, right? I understand. Thanks. I thought I hit control there. Yeah, so that's like the ideal scenario. That's kind of what you do with Dune. You're going to install a Dune. You're going to install Dune, and then you're going to start using Dune with like this Dune init project name. This is probably too simplistic as well. As you can see, Dune extrapolates further. We'll probably also have to extrapolate further, because I'm sure we'll want to use this command for additional things, like, creating a new page or creating a new whatever, something like that. So, need to figure out how does Dune do that? Like, how do we create something? What did I call this? We started working on this. Maybe we didn't. OCaml landing, OCaml repository, OPAM repository. Huckabuild, yeah, it was huckabuild. Yeah. Alright, so we've got this project. I think it does build, but I don't know if it actually works to like install things. And we started doing some stuff with this part. So it runs huckabuild. The final function will be executed by your command. Run huckabuilds. Takes a project name. It does a create project on project name, and then it invokes Dune. So let's see. It defines the project name. This defines your command. A tool to create and build OCaml projects. Actually, we had an AI scaffold this last time, and then we just cleaned it up. So we need to spend a little bit of time this morning just trying to figure out exactly what it is that this does. Because obviously we don't vibe code here. We might ask AIs to build things, but then we meticulously inspect them, tweak them, change them, update them, and make them good. Because that's the way programming is supposed to be done. Alright, so we've got a command. What does command.eval do? Let's see if the LSP will tell us. Command eval is a, let's see, do I do that? No, that's it, huh? Okay, well, time to Google. OCaml command.eval command liner. Okay, so that's from this command liner package. Apparently not. Kind of seems like command liner doesn't exist anymore. What's going on here? Okay, there we go. Command liner provides a simple and compositional mechanism to convert command line arguments to OCaml values and pass them to your functions. Module automatically handles syntax errors, help messages, and Unix man page generation. It supports programs with single or multiple commands. Maybe we just need to ask Gemini about. I want to create an OCaml app that can be installed and then used independently. Can I spell? On the command line, much like dune is able to be used. Well, first, is this possible without some, I don't even know what to say, like some sort of weird connection to the OPAM crew? Like if you're not working on one of the OPAM languages, or if you're not working on OPAM or one of the OCaml languages, like can you actually do this? I'm wondering if dune just has like some sort of like a secret in, maybe not secret in, maybe just a regular in. Get this in the middle. Yeah. Is this possible for me to build right now, or do I need permission/help from a source at OPAM or OCaml, etc.? Let's just read this while it does that. So we've got, this is our command liner command. So we're getting a version info. We've got our doc information is a tool. This is what the command line man page, I guess, will essentially have. That's not what I asked. OPAM reads the MyCLI app OPAM file, which dune helps you maintain, builds your project, and copies the resulting executable into a directory that's part of your system's path. Okay, maybe this will work then. Alright, so command line, let's see. Doc overrides the default message to print. env. Excuse me. Our env. Why is there two doc? Doc, env, doc. Arg.value term for, okay. Alright, come back to the top. How do I cmd dot eval? No. Okay. What about just eval? So far, oh, term.eval is right there. Term.eval. Is command not command liner? It sure looks like it is. Sure seems like CMD must be command liner. Let's see. Command line syntaxes are explicitly defined by terms. The command value behind the syntax, etc. Okay, so maybe this isn't command liner. Let's see. I really just want some examples of command.eval, command.info. How about just OCaml CMD module? I don't know. No. Command line parsing. It's always a good day when we're in real world OCaml. It still isn't like, I need to understand arg versus command versus term, but I don't know where to find any of this information. I guess that's the real use for AI here, right? Grab that. CMD and term. Alright, I'm gonna blow my nose. Hold on a second. Let me mute so you don't have to hear it. We're back. Alright, let's see. Deep dive into command liners, arg, command, and term modules. Okay, so it is command liner that we're doing. Arg, defining the building blocks of the arg command is a toolkit for specifying individual arguments. That's this, right? So this is arg.required. Arg should be at position 0. It should be a string. I don't understand this. Let's break down the definition. Arg required. The function indicates the argument is mandatory. Automatically generate an error message. Oh, right. So and means that this is now arg dot position 0. Positional argument index 0, meaning the first argument that appears in the command name itself. Some string, this defines the type of the argument, so this is arg some string. The sum constructor wraps an object type, but in conjunction with required, it ensures a string is present. None. This would typically be a default value for an optional argument. Okay, so there's no default. It must be a string. It must exist. It's at first position. It needs to be a string. There's no default. And then info, arg.info, brackets, docv project name, doc. This function, so this is a function. This part's a function. Provides metadata for the argument, which is used to generate help messages and documentation. An empty list for the argument names, right here. So arguments would go in there. The docv project name, this sets a placeholder name for the argument's value in the help text, making it a more descriptive for the users. So project name is what, when it shows the man page, I guess, it would be like, you know, HuckaBuild project name or something like that. And then doc, so this is calling doc, which is the name of the new project, which is a description help text for the purpose of that argument. So this is defining one single argument It's a required argument that comes first. It has to be a string. It does not have a default. And it will provide project name as the placeholder for itself in messages, and the description of the field is the name of a new project. All right. Perfect. Now on to the next thing. Now we've got command.info. Oh, it's talking about term next. This is the logic of our command. Okay, so that's fine. We'll do this and then we'll do command. It does do command, right? Okay, command, bring it all together. Okay, cool. So term modules where you define what your program does with the arguments it receives. It allows you to create terms, which are essentially computations that we performed based on the parsed command line arguments. These terms are then combined to call your application's core logic. The key to term is its applicative functor style. You can think of a term as a value that will be available in the future once the command line has been parsed. Okay, so this is term.const run huckabuild and term.project name arg. Right, so term.const run huckabuild runs huckabuild, so that's this command. So this is setting up a term that will run this run huckabuild with a project name to create project and invoke dune. The const function, so term.const, lifts a regular OCaml value, in this case the function run huckabuild, into a term. So this creates a value in the term for run huckabuild, I guess. It just ports run huckabuild into the term. This creates a term that when evaluated will simply be the run huckabuild function itself. So we're packaging things into a term. So we have to have a term, and so we're just stuffing stuff into it to try to make it work. So we're first stuffing this function in, because this is our important function, right? This does all of the project creation and dune invoking. Then we're going to use an infix operator, this $sign from the term module. So this is also term.$sign. And that module that applies a term containing a function. This is an infix operator from the term module that applies a term containing a function to a term containing an argument. It's the command liner equivalent of function application. So this says take run huckabuild and pass it project name as its argument. So it's taking this infix operator is taking this argument and stuffing it into, or being used as, the value, the parameter, the argument, if you will, for this function. So it's creating a term that includes the function run huckabuild with the project name argument as its first argument. And it's this project name argument is this guy, which we just talked through up here, which is a required first position string with no default that has some simple info text. Cool. So the expression constructs a new term. When this new term is evaluated, it will take the evaluated value of project name arg. I feel like, yeah, no, never mind. It'll take project name arg and apply it to the run huckabuild function, so you connect the parsed command line arguments to your program's logic. This is really confusing, I feel like, but I guess this could make sense, right? You can make several of these and then just append them all together with $signs in here. Maybe not too bad. Maybe not too bad. All right, now let's look at command. Command is the one that we're more interested in because it's got this info, v, and eval. Eval appears to be running the command. I think that's just obvious, I think, at this point. Let's see. Command.info. That's our first one here, huckabuild. This function creates the informational record for the command. Huckabuild is the name of your command line tool. Docs provides a top-level description of what the tool does, which will be prominently displayed in the help message. Prominent. Love that. Command v info. So we're taking that info object that we just created, the info whatever block, and we're passing that to command.v. This function creates the actual command value. It takes the info record and the term that represents the command's execution logic. Okay, so this takes the info and it takes this term, which we talked about how it's just taking the project name and applying it as an argument to this run huckabuild function in a term, taking the info, taking the term, and creating an actual command. So its return value, which is getting stored in command, or CMD, is the actual command itself. And now the huckabuild.ml's actual build executable, since this is our main function down here, is going to exit after command eval. And command eval is the entry point for the runner of the command line application. It parses the command line arguments, sys.argv, it evaluates the corresponding terms, handles errors, and displays help messages as needed. The integer returned by command.eval is used as the exit code of the program. Right, so we run this and pass its result to the exit function. All right. I think we have a pretty good idea of what's going on here now. Let's save that since we've putzed with it a little bit. And then let's look at huckabuild lib. All right, so this is the one that we spent a bunch of time on last time I streamed, which was, I don't know, like 60 years ago. So we're creating a project. It's going to take a project name. These are also the two functions, right, that we just saw before. If you come back over here, this is our create project and our invoke dune. This is the actual implementation of those functions. This is going to make directory with that project name and give it the 755 permissions. So this is permissions. Owner has 7, read, write, execute, and then group and other have read, or have, yeah, read and execute. Just read and execute. This has 1. I don't remember. I think it's read, write, execute, read, execute, read, execute. That's 755. If it was 6, then they'd have write, execute, write. I don't know. It's been too long since I've had to do that. I would Google it. Anyway, it's not important. We're giving it 755 permissions. If you know what that means, great. If you don't, then go Google, let's see, chmod 755. Numeric corpus decision 7 for the owner represents read 4, write 2, and execute 1. There you go. Pause the video here if you're on YouTube. Also, while you're paused, like and subscribe. Moving on. All right, so we're going to open a project file called main.ml inside of our project name directory. We're going to create a file writer to main.ml. We're going to output a string into that file that's basically just this hello from your new project, which will replace all this because this is not what we want, but for right now, it will do. Then we're going to close this file handler, and then we're going to open up or create a second file handler, which opens out project named the dune file. We're going to output some strings into that dune file, specifically just we're going to create this executable main. And we're going to close that, and then we're going to print to the screen, hey, we successfully created your project, here's the project name. And then if anything happens during all this process, we'll create an error message that says error creating project. All right, to invoke dune. Now, if you remember from our Excalibur drawing, what we want to do initially is that we want to create this project. My initial plan had been to do the dune invoke dune first. This feels like it's doing stuff I don't necessarily want it to do. I'm confused about why it would do this one first. I don't know what dune does if there's already a directory that has that name though. It may just orchestrate inside that existing directory. I think the only way we'll know for sure is to try it. But let's look at this really quick before we do. So invoking dune, it creates a process called dune and runs dune build. It saves the PID from that command, and it also gives it standard in, standard out, and standard error from Unix, unix.stdin. So it's going to create a process with access to those 3. It's going to call dune in that process, and it's going to be the dune build function. It's going to keep the PID, and it's going to watch and wait on that process ID and see if it exits with a 0, which is good. Then it's going to say the build happened successfully, and then if it exited with any other value at all, then it failed, and it'll show us why it failed. Well, it'll show us the error code, and then we'll be left to search the abyss of the internet to figure out why that error code's bad. And then if we get an interrupted, like if it didn't exit, if it was actually signaled or stopped, then we'll just say, hey, it was interrupted by a signal, and we stopped. That way we kind of know, hey, what happened, was stopped in the middle. I don't know what's left out there. All right, so let's, actually, how do we run this? So we do a dune build, and if I do dune execute, What's our dune file look like? Let's go to dune. Okay, we got public name HuckaBuild. Do we just do dune execute HuckaBuild test? Error creating project. File exists. Oh, I've already created test file. Nice. What's in test? Test is a directory. Oh, right. Never mind. I'm just an idiot. Don't create one called test. Call it strawberry. Successfully created project strawberry. Dune build successful. All right. What did that do for us? If we look at strawberry, it created a file. It's got a dune file. It's got a main.ml. I don't see how dune build was successful. I guess it went in and it did a dune build. I feel like I'd rather just have it use dune init project to create this new directory, and that would be significantly easier. I feel like I'm trying to lift. I feel like this AI generated one is trying to enlift, or is trying to do way more than it actually needs to do. But, you know, sometimes that just is how it is. Upside though, if we go into strawberry, it actually did build things the way we expected, so that's cool. RF. Be gone, strawberry. Alright. Let's take a peek. What if we what is this? HuckaBuild library? HuckaBuild lib? What if up here, what if we do invoke dune first and then create project second? Right, so if we take this, so invoke dune, this is actually just doing dune build. This isn't actually creating a new project. This is just doing a build. So it's going to create a project. It's going to drop files into it, and that's going to go in and do a dune build and just see if it works. Which, I mean, I guess that's fine. But I still think that we want to do this dune init project first. So maybe we try that and see what that gets us. So we want to do, let's move this up. Take this, there we go. Let's not call this create project, let's call this scaffold project. Whoops. It's gonna be mad about that, but I don't care. Don't care. Don't care. All right, so invoke dune, we're actually gonna pass this project name as well. And then, yeah. I don't think dune takes us into the directory. I guess we'll find out here in a second. So let's come back over here. We've got invoke dune, and then we've got create project. We're gonna call this scaffold. All right, so let's actually change the order of these because they happen in a different order. And I think keeping them in the order that we execute them is valuable. Because that's how we're going to be looking for things, right? Like if we're looking for an issue, we're going to, yeah. It'll just make more sense semantically. So we've got invoked and we've got scaffold project. Let's grab this. We'll drop a project name in there. This time we're going to do dune build. We're going to do dune create process dune. This is the name of the process, and this is the actual command we're giving it. So we're going to do dune init. I'm winging this right now, so bask in the glory of that. Proj, and then we're going to give it project name. Nope, not a capital. There we go. All right, so now we're using that. So now we're going to create a new process, this one called dune, and it's going to have dune init project name. So dune init project name. Good, love that. It's going to do its thing. And it's going to say dune, let's say dune setup. And then this will be, nope, dune setup failed. And then dune is interrupted by signal. So cool. All right, so this will now take our project name. It will duneify it. Now this project, I instead want, I think we still need to be able to go from here. When we create a new dune project, we're already going to have a bin directory. We're already going to have a executable, a Dune project. We're gonna have a lot of good things already, which is good. I'm trying to think of what we need to actually do here. Let's call this something else. Let's call this initial.ml. Project name, we're gonna call this /bin/initial. So we'll put it into our bin directory because Dune should have already created a bin directory. So we're gonna create this initial file. I actually don't honestly care about this initial file, but I need to see that it works, so we're gonna do it this way. I don't actually know that I want to do this part right now. Let's see, let's just take this part out for now. Successfully scaffolded project. Okay. Now let's see how badly broken things are. Not broken at all. That's exciting. So we'll do dune exec huckabuild, and then we'll do strawberry again. All right, entering directory strawberry. Success. Initialize project component name strawberry. Leaving directory strawberry. Dune setup successful. Error. Creating project file exists. All right, let's see what it actually did. It seems like, sorry, I can't point to my screen. It seems like this makes me think maybe we were already in there. We got Dune setup successful. We got error creating project though. Not Dune. Build _lib. Dune setup successful. And then we get error creating project already exists. Oh, because we're still doing this. Ha! Yeah, sorry. That's not gonna work. Alright, so let's rmrf strawberry. We're not even gonna look in there. We're doing this blind. Because we believe. Boom. Successfully scaffolded project strawberry. So initialized project component named strawberry. So if we ll into strawberry, we'll see that we now have a complete Dune package with OPAM, with lib, with build, with all that stuff. And then if we do an ll strawberry bin, we'll now see we also have our initial.ml that we created. So awesome, we've now scaffolded that. Now, so we've run our Dune init project. We've seeded into the directory. We've created a directory structure that we define, which is just initial ML for right now. And then we want to create a basic landing page. So we need we'll have to brainstorm that a little bit because we need to actually build a landing page. We don't have a ton of time. We've still gotta get off again here pretty soon to go take care of some errands. So we'll see how much further we can get before that happens. All right, so we need to brainstorm here. What do we want this directory structure that we defined? What do we want that to look like? What do we want our basic landing page to be? We've got a lot of options. Now that we know how to do everything, presumably. Oh, interesting. Yeah, we should also think about this. We've also only done this part. We've only done we've only done the command generation part. We also need to do the running executable part, which is going to run Dune exec project name, and it's also going to build JavaScript. That's something else we're going to have to do. We are going to have to figure out how to build JavaScript. Yeah. So we'll have to decide what library we're going to use for that. JSO, OCaml, MLX, Melange, something. But we have to have JavaScript. As much as it pains me to build with JavaScript, since that's what I do all day, every day anyway, we do need it. We can't build a web app without it, because that's what the modern web runs on. It runs on JavaScript. JavaScript is the assembly of the browser. So let's see. Let's first delete strawberry, because we don't need that anymore. Let's pop back into huckabuild. Let's see if we can create a second command. Not sure. I've got to make sure I understand this. Is huckabuild just the command? Okay, so we actually need, right now we've got command name project, but we need command name init project name. So we actually need a second command. Okay, let's see. This is our project name arg. Let's just start by creating a new argument. Let command type arg. So let's let doc. We'll just copy this one for the most part until we get to where we can't. The huckabuild command to execute. Executor. Alright, so we do that, and then we have to create the actual arg. Put these in parentheses. This is a required field. And this should actually be at position 0. And it should be some string. And it should also have no default. And the info that we're going to pass is nothing. And then it's going to have the doc v of command. What is doc? Oh, doc is that. Okay. Doc. All right. So we've got this command. This is the real position 0 command. This is interesting though. Project name will not always be required. Depending on the command will determine if it's required. Which also means that huckabuild isn't necessarily going to get this project name either. Well, run huckabuild should. This should be for setup or for init. Let's see. Start at the bottom, right? So command.eval actually evaluates the command. This is where we create our command. Huckabuild doc. Run huckabuild. $sign project name. So this is the all of it gets this, right? The huckabuild file generates this individual command. So does this mean that we really want to have a command per file? That seems unlikely. It seems like this command, I need to like build a command based on what arguments I've received. I need some kind of like a switch here. Actually, we've got Gemini up here. How might I modify this OCaml file to support both of the following commands? Huckabuild init project name huckabuild run where project name is a string passed in by the user. And init/run are strings that are also strings that the user passes in to differentiate between different command actions. That's super weird and hard to phrase. We'll see. Just, I don't know, maybe computers understand me even though people don't. So we've got this command. It feels like we need more than one command. We need some sort of a way to like differentiate between commands. So we know that this HuckaBuild is the command info, right? Multiple command.t values. Okay. Alright, so this creates a main command. And a main command is going to give us information that we don't have. So this is going to be command info HuckaBuild, command group info, init command, run command. Oh. Hello. Use command.group to create a parent command. It takes the parent's info and a list of the subcommand, command.t values. Command line will automatically handle dispatching to the correct subcommand. Gosh, I love it when things do things automatically. So good. All right, so run HuckaBuild, run project, got init command, run command, project name argument. Okay. Let's take a look. Let's see if, let's just take the whole thing. Boop. Alright. I wouldn't normally take the whole thing, but I'm in a time crunch. Alright. Let's find a separate function that will be executed by each subcommand. So here we've got init project with our project name, initializing new project named. Okay. So initializing new project. I don't want this to say this. We'll see though. Executing the run command, build and run process finished. Here you'd invoke the build and run process, HuckaBuild lib.invoke dune. Yep, this would be an invoke dune probably. Here you'd call your library functions. Okay, cool. So it's only scaffolded. Now I shouldn't have deleted all that. Undo. Oh no, I guess that's fine. Because it's got HuckaBuild lib.invoke dune. Okay, I kept everything. Alright. Redo. Boop. Alright. So here in our init project, action for the init command, it's gonna accept the project name, and it's gonna say initialize a new project named blah, and then here we're going to take this out. We'll do create project. It doesn't have create project though. It has scaffold project. Ooh, we should probably create that. We should change this invoke dune, right? So this should actually be HuckaBuild lib. Whoops. Hello. HuckaBuild lib dot invoke dune project name, which will create the project, and then we should scaffold project. Okay, so that will work, right? This is what we're doing already. This worked, quote unquote. It did random stuff. So does that here run project? We're gonna have to create a new one because invoke dune is already doing something else. We'll rename invoke dune to be something like, I don't know, dune create project, and then we'll call this one dune execute or something, because we do want dune to do the executing. That just makes the most sense for us here. I think it makes the most sense. I don't know. That's gonna be an interesting question. We also have to be thinking about how we're gonna run this app. We'll probably want to build some kind of like a Docker container or something like portable so that we can, I think down the road, we're going to have to build a service or a system that deploys these particular apps, kind of like Vercel does. I think I talked about that last time, like Vercel or Laravel Forge or a bunch of other places. I really want to optimize our build so that whatever we build to actually deploy these things will be like simple and streamlined. No one's deploying OCaml apps. I can't like design this to be really good fit for a different system because there just aren't any big commercial customer-facing systems. So we're building one specifically for us to use, but also specifically so other people, if they want to build things in OCaml, they'll be able to use it. It'll be simple, it'll be straightforward. There won't be a lot of frills to start with, but it's a place to get started, and it's gonna open up the ecosystem a little bit, I think. So we've got our init project working, run project, we need to build this. Print end line is gonna have, oh no, sorry. Define the command line arguments required by subcommand. So here we've still got our project name subcommand. This is only to be used by the init command, totally unchanged. And then we have to create our subcommand. So looking at these, right, we've got our doc string, our info, which just is that this is the init command for doc. It's going to take the term init project. This actually looks exactly the same as it did before, right? This is this one. Our info is command info init with this doc. So this is the actual command, right? This must be how it automatically does it. We're telling it through the info field that this is the init command. This is the run command. So it's going to do that. And then this one is going to do the same thing, except it's going to just pass the command to run project, and it's going to pass in a unit. I don't know why it's term.const. We're just creating a unit function here, I guess. Or we're just creating a unit object and passing it as the parameter to run project. Because run project expects a unit or parameter. That's fine. So a tool to create and build OCaml projects. Huckabuild. All right. Let's build first and see how it works, if it works. All right. We already deleted strawberry, right? So then we can do Huckabuild. We have to do dune execute Huckabuild strawberry. Unknown command strawberry must be either init or run. Ooh, excellent. So Huckabuild init strawberry, entering directory strawberry, initializing component, leaving directory, initializing new project named strawberry, dune setup successfully scaffolded project strawberry, project structure created. Now we did a quick peek at the internals of strawberry, and look at that, everything is as expected. And we've got our initial.ml in there, which is our one-off file. All right, so now blow away strawberry. Don't need that anymore. Now we've got ourselves a working scaffolder. Huckabuild. All right, so actually we need to go to Huckabuild lib, because now we need a new one. So invoke dune doesn't make sense. We should change this to be init dune, because that will make more sense. And then let's come here, and we'll do init dune, and then we'll come back here, and now we need project name. So we need another dune one. Actually, what order do we do these? We got init scaffold, and then actually we probably should just group all the dune stuff together. I like the idea of keeping them in order that they're being used, but dune related functions will be up top. This one will be, wait, why would I do that? This will be file system related functions. And then we're just gonna grab this. Drop this in here, but this will be run dune. I don't want the project name. I want this to accept a unit. But now we have an interesting dilemma. I need to be able to run dune, but I don't know how to tell it which file to run. OCaml projects can have multiple executables. I wonder if there's something in the dune project maybe that, whoops. It really isn't. makes me think that I'm gonna know what I'm doing. Let's try this one. So this gives us an executable. Maybe we could just tell it to execute the first executable. Does dune exec have like any sort of is there any sort of like default option? Public name. Public name, yeah. I feel like we could just pop open that file, find the public name, and then pass that to our create process. I think we should create a, I guess these are utility functions then. Utility functions, yeah. Functinos. They're obviously the more fun version of functions. Let's see, let scrape project name. I almost feel like we could just create a file here. We could create a file on our scaffold, like a dot file of some sort, and have that file just have the information we want here. That way our run dune could open our file, our .huckabuild file or whatever we're calling it, and it could look for a specific field in the .huckabuild file, and that would tell it which file to run. Oh. Actually, I feel like that might be the right option here. Let's temporarily take this. Let's comment that out. Let's go. Oh wait, it's down here, right? Scaffold project. Yeah, so we're gonna create this. Let's bring this back. And let's say create the .huckabuild. What is this? This is a meta. So open out project name .huckabuild. So this is going to create not a dune file. This is going to create huckabuild file, and we are going to put in that file. Oops, no, undo. They're already lowercase anyway, it doesn't matter. We're going to put in that file executable name main, but we want project name here. Let's see, how should we structure this file? I think it could just be like a .env file, honestly. Just everything could have its own little line. I don't know, it seems super easy. If we did that, maybe we could just ingest it. No, if we make it a record. We have project name. And then do project name. Should we do a colon? We're doing equals. That'd be easier. Project name equals. That's how env files work, right? They have an equal sign. So we do project name equals, and then the project name, and then whenever we're unwrapping it up here, we can open this file, look for project name equals, and just take everything immediately after it until the end of the line. that's that. Don't even need to do this anymore. None of this is in Git, by the way, so we should probably rectify that situation very shortly. Alright, so that's going to build our HuckaBuild file. So if we do a dune build, make sure that's all cleaned up still. We execute, look in Strawberry, and there's HuckaBuild. Strawberry.huckabuild, and that gives us project name Strawberry. Okay. I like the idea of a metadata file. I like that gives us some more stuff. Let's get rid of Strawberry. Let's also get init in here. Get status. We should get rid of. We need to create .getIgnore. We just include build in here. Get status. Cool. Bin. Dune project. HuckaBuild.OCaml. Yeah, I think these are all good to be in there. We don't have anything sensitive in this project for once. So let's git add. Initial setup with scaffolding and dune in it. Alright, I'll have to push that up to GitHub a little bit later, probably while I'm working. I've got lots of time-consuming things to do at work today, so we'll see if I have time. But it is 8:24, so this is probably going to be where the stream's got to stop, or the video stops. Again, if you're watching on YouTube, like and subscribe. Yeah, so let's circle back. So we have done all of this now at this point. Well, we've done this. We've got our command. Whoops, don't move. We've got our command, project name. We've got this. It takes a command name, which is init. Or sorry, no, command name is HuckaBuild. We're using HuckaBuild. So we've run HuckaBuild init project name. That works. Now we're working on HuckaBuild run. So that's going to be tricky because we need to know what the project name is. But we're going to use our dune HuckaBuild. So let's actually do this. Pull project name from .huckabuild. Cool. So now we're going to pull our project name from .huckabuild. We'll do build a dune exec with that project name. And then we need to build the JavaScript. We'll probably need to do these in threads or something. The real key here is that we do not want people to have multiple terminal windows open in order to run this framework. We want it kind of the way the Laravel does it, or the way that Next.js does it. We want to just have one command that starts everything, that does CSS compiling, does JavaScript compiling, that builds the directories and stuff. Essentially, we probably want to do like a watch. We'll probably want to have like a run, and we'll probably also have like a dev. Actually, let's... Can I move this? No, you're not going to let me? Okay. So let's add another one here. This will be run command name dev, and it's going to pull project name from .huckabuild. It's going to run dune exec watch project name, and it will also do the build JS CSS etc. Let's put a colon here, keep it consistent. So this will still have to come. Why are there so many? There's so much gap here. Yeah, so this dev command will have to come. Run is what we're doing next. Run is going to be like your production level. Like you run in production. Yeah. All right, this is where we have to stop. This is where we've got to stop. It's been a lot of fun. Hopefully that we'll have something that's playable, interactable with in the near future. And yeah, we'll see how it goes. Until next time, keep on building with OCaml.